Core concepts in class questions. Question 3. A student carried out an investigation to investigate the effect of temperature on cell membranes. What are they doing? They are got a test tube, and we've got ethanol, and we've got our little bit of beetroot there. Okay, and then eventually the ethanol solution is going red. And the time taken at different temperatures, and we've got some repeats and a mean. Okay. Calculate the percentage decrease in mean time. So mean time, so there. For the ethanol to turn red between 15 and 30. So these are the numbers that we're actually using. So a percentage change, be it an increase or a decrease, is the change divided by the start value times by 100. And so our change is this. It's gone 447.7 minus 329.3 divided by the start, so between 15 and 30, so 15 is our first one, 447.7. I'm doing this step by step. So 447.7 minus 329, that's 118.7 divided by 447.7. So 447.7. Then we times it by 100. Times it by 100. $26.5. So double check that. We got 447.7, 447.7 minus 329.3. 447.7 minus 329.3. Oh, there you are, I see, done it wrong. 118.4. 118.4 divided by 447.7 equals 26.4. 26.4. And that's our percentage decrease. 26.4. Moral of that story? Check your calculations. Using your knowledge of the structure of cell membranes, so our knowledge of the structure of cell membranes, our cell membrane knowledge is this. We've got phospholipid bilayer. That's the barrier around the cell. Why ethanol causes a pigment to leak out? So we've got the pigment inside the cell. It can't get through this layer, but ethanol dissolves this layer here. So ethanol is an organic solvent, so it will dissolve the lipid component, and so that will create gaps, and the red pigment can go through. So we just need to put that into words. So ethanol dissolves the phospholipids, or you might have just said the lipid part, and that creates gaps in the membrane so it can diffuse out or leak out. What conclusions can be drawn from this experiment regarding the effect of temperature on cell membranes? So really they are wanting some science here. And as we are talking about temperature, then we're going to talk about kinetic energy or movement of something. Okay, we've got 3 marks here, so we're going to have to say 3 separate points. So what does temperature do to anything? Temperature, so increased temperature increases kinetic energy of the membrane particles, dye molecules, of, let's just put molecules there to fit it in. And then that movement will increase the number of gaps in the membrane. So more gaps in the membrane, and so if we've got more gaps, more dye molecules can escape from the cells, so more dye or red stuff can escape from the cells. A red herring here, if you excuse the pun on the red. The more kinetic energy will make diffusion faster, but really it doesn't matter how fast diffusion goes if this membrane is stopping the dye from going through. So in this case it's not really fast diffusion, it's the structure of this membrane. Comment on the validity of your conclusion. So really anything that's valid, that's really saying, is it true? Is it right? And to do that we need to look at our experimental results and go, do they really support this conclusion? What could we pick out from there? And so things like, if they hadn't done any repeats, then we could criticise that, but they have done some repeats. So I'd be tempted to go, yeah, we've done repeats, obtained a mean, that would make my results valid. So I'm going to put that down. It's not actually in the mark scheme, but I think it's something, results are repeated and means calculated, so valid. And we can possibly come up with some reasons as to why they would be less valid. So for example, if we look at the range of data, well, at 15 degrees the raw data is quite close together, whereas at say 45 the numbers are from 99 seconds all the way up to 215 seconds, so it's quite a range of data for 45. So some raw results range big, e.g. 99 to 215 seconds, at 45 degrees C, so less valid. So there's one of each there. Other possible, so we've got the 2 marks there possibly, but other things we could have said. Well, we only looked at 3 temperatures here, so we could have looked at more temperatures to make the results more valid. We could have improved our method. We're kind of judging when this red has leaked out, but when do you actually stop your stopwatch? It's hard to tell, so we could use a colorimeter or some other piece of equipment. So hard to judge the colour endpoint, so less valid, or only 3 temperatures looked at, so less valid. So 2 of those for those 2 marks there.